The strangest part of the moon was not the side hidden from Earth, but the way it made Earth look like it was falling. No one expected a mission billed as a test flight to hand us one of the rawest human views in space since Apollo. Stay with me, because what the Artemis II crew saw behind the moon was not darkness at all, but a place bright with shadow, silence, and shock. And before we go farther, subscribe if you want more clear-eyed space stories landing in your feed while the discoveries are still new. For most of us, the far side of the moon lives like a rumor. It is the place songs call dark, posters paint black, and old spacebooks treat like the back room of the sky. But on April 6, 2026, 4 people finally came around that corner in person, with windows, cameras, checklists, tired eyes, and very human voices. And what they described did not sound like fantasy at all, which somehow made it feel even stranger. This crew was not there to plant a flag, drive a rover, or bounce across dust in slow motion. They were there to test Orion, the spacecraft, and prove that people could travel deep into space again and come home safely. That is what makes this story better, because the mission many people treated like rehearsal turned into one of the most important acts of seeing in years. It was the underdog version of history, the kind that walks in quietly and leaves the whole room different. NASA astronauts Reid Wiseman, Victor Glover, and Christina Koch flew with Canadian Space Agency astronaut Jeremy Hansen. They launched from Kennedy Space Center in Florida on April 1, 2026 at 6:35 p.m. Eastern Daylight Time. What followed was almost 10 days and roughly 695,000 miles of motion, waiting, testing, watching, and learning how space feels again when people are inside the machine. And somewhere in the middle of all that engineering, the moon turned from a symbol back into a place. To understand this, we first need to go back a long way. Most people say dark side when they mean far side, but that is wrong. The far side gets sunlight too, just like the front does, because the moon turns and day moves across it. It is hidden from Earth, not hidden from the sun, which is a small correction that changes the whole story. The moon always keeps one face toward us, like a dancer who never stops looking at the same partner. That trick is called tidal locking, which just means Earth's gravity slowed the moon's spin until both motions matched. So the same front stays aimed our way, while the far side remains out of sight unless a spacecraft goes around it. For generations, that made the far side feel less like geography and more like a sealed door. That sealed door feeling lasted so long that people filled it with guesses. Maybe the far side was smoother, maybe rougher, maybe darker, maybe more dangerous, maybe basically the same. Robotic spacecraft helped, of course, especially after the Soviet Luna 3 mission first imaged it in 1959. But a picture taken by a machine is not the same as a human being pressing a face near glass and trying to understand what the eyes are telling the brain. Artemis II mattered because it brought human sight back into deep space for the first time in more than 50 years. This was the first crewed flight of Orion and the first time astronauts rode NASA's giant Space Launch System rocket. At liftoff, that stack weighed about 5.75 million pounds and pushed upward with 8.8 million pounds of thrust. That is such a silly, huge number that it helps to picture a tower of metal the weight of a warship being thrown skyward by controlled fire. The first minutes were all violence and timing. 7 seconds after launch, the rocket cleared the tower and rolled into position. 56 seconds in, it went supersonic, and by 1 minute 12 seconds it hit max pressure, the hardest shove of air on the climb. Then came booster separation at 2 minutes 9 seconds, like giant spent muscles peeling away after doing their job. After that first roar, the mission changed character. The crew moved from thunder into long patience, from launch drama into life inside a moving room. NBC News reported that Christina Koch described Orion's habitable volume as roughly like a camper van, which is perfect because it makes deep space feel strangely domestic. Even beyond Earth orbit, people still need sleep, checklists, food, clean socks, and a place to put their elbows. That smallness matters. We talk about the moon in giant words, but the people going there still open pouches, strap themselves in, and watch lights blink like a kitchen appliance doing honest work. The spacecraft that carried them toward the far side was not a glowing silver palace. It was a hard little shelter, more like a survival cabin with software, which made the human view out the window feel even more precious. The first surprise was not a crater, or a mountain, or a perfect photo. Scientists expected the far side to feel familiar once the crew got close, maybe like seeing the same old face from a different lamp angle. What the crew actually found was something subtly wrong, and that wrongness hit first. Christina Koch told NBC that the darker parts were not quite in the right place, like a face you know well, but the features have shifted just enough to make your stomach notice. That reaction is so human, and that is why it matters. If a map says one thing and your senses say another, your body often speaks first. Cook said something and you can feel that this is not the moon you are used to seeing. It was like walking into your own kitchen at night and finding every chair exactly where it belongs, except somehow the room still feels strange. If one image from this mission would stay with you the longest, which one would you put in the comments? Your comment helps me see which parts of space stories you want explored next. Because once the crew got deeper into the flyby, the moon stopped feeling merely unfamiliar. It started giving them views that even Apollo crews never had. That point surprises people too. We often hear that Apollo astronauts already saw the far side, so what could possibly be new here? But Artemis II flew a different path and reached a different distance, high enough that some features could be seen in ways no human eyes had seen before. NASA said the crew traveled upward of 8,000 nautical miles beyond the far side, which changes the geometry like stepping back from a painting until the whole thing suddenly makes sense. At 12:41 a.m. Eastern Time on April 6th, the crew entered the moon's sphere of influence. That is the moment when the moon's pull becomes stronger than Earth's for the spacecraft. Later that day, the official flyby began, and the moon turned from destination into landscape. From there, every mile closer sharpened the difference between what was expected and what the windows delivered. The second finding changed everything. Mission scientists expected the crew to get powerful views of the moon's battered geology, especially the far side's giant scars. What they actually got was a broad, human-eye look at structures so large they almost refused to fit inside thought. Imagine standing close to a wall for years, then stepping back far enough to see the whole crack spreading across it. One of the most important features was the Orientale Basin. Nature published a report on April 4, 2026, by Alexandra Whitsey, explaining that mission scientists were especially eager for the crew to observe it. Orientale is a huge, multi-ring impact basin, the mark left by an ancient blow so violent it rearranged an entire region of the moon. It is not just a hole, but a frozen ripple, like what happens when a pebble hits water, except the splash became stone and stayed that way for billions of years. That is where scale gets slippery. A crater in your mind might be the size of a field, or maybe a town, but a basin like Orientale sprawls so wide that it behaves more like weather on a map than like a dent you could walk around. The far side makes you keep resizing your imagination until your brain feels like it is pulling a bedsheet over a mattress that suddenly got bigger. NASA also warned that the lighting would be hard to predict exactly. The sun's angle on the moon shifts by about 1 degree every 2 hours, which means the same ridge can look blunt, sharp, or almost invisible depending on timing. Scientists expected a useful view. What the crew actually saw was light scraping across the surface so low that every wrinkle stood up like a crease under a flashlight. A NASA image released from the flyby showed part of the moon along the terminator, the line between lunar day and night. There, features such as Jewel Crater, Birkhoff Crater, Stebbins Crater, and nearby highlands rose into view through long, dramatic shadows. Expected, a gray world. Actual, a relief map made of knives and ash. The comparison that fits best is a rumpled blanket at sunrise, when every fold suddenly looks deeper than it is. 3 hours into the lunar observation period, those shadows became almost the whole story. Low-angle light did what overhead light never can. It turned the far side from a flat coin into a carved object, full of ridges, rims, walls, and basin edges. Like the tiny bulb inside a refrigerator showing the texture on a cake better than a bright ceiling lamp, the moon revealed itself by not being lit too evenly. What changed for you first, the science or the feeling? And would you like the video and tell me why it matters? That kind of helps the system notice that careful science stories are worth showing to more people. Because the next surprise did not stay on the moon at all. It reached back and changed the way Earth looked. Halfway between Earth and the moon, the crew found a view almost no one on Earth ever imagines clearly. Reid Wiseman said the Earth was almost in full eclipse, while the moon was almost in full daylight, a sight only possible from that in-between place. Scientists expected a beautiful transit through space. What the crew actually saw was a relationship, not two objects, but a live geometry of shadow, brightness, distance, and motion. That matters because human beings understand space badly when everything is too large. So here is the kitchen table version. Picture holding a white dinner plate in one hand and a blue marble in the other. Then dim the room until one shines and the other nearly disappears. Now move until their light changes places, and you get the emotional logic of what the Artemis II crew saw out the window. The third discovery was not one image, but a change in viewpoint. Apollo gave us Earthrise, that unforgettable moment when Earth seemed to lift above the moon. Artemis II gave us Earthset instead. At 6:41 p.m. Eastern Daylight Time on April 6th, according to NASA Earth Observatory, the crew captured Earth appearing to sink below the lunar horizon. Scientists expected something like the old Apollo magic. What they actually got was the mirror image, and mirror images can feel more intimate than originals. Earth did not climb into view like a hero entering a stage. It slipped away. It was like watching the porch light of your own house disappear behind a hill while you are still close enough to know exactly which home it is. Katherine Hansen wrote about that image for NASA Earth Observatory on April 10, 2026. She explained that the shot showed a partially lit crescent Earth dropping behind the moon during the far side pass. White clouds and blue water were visible over the Oceania region, while the darker parts marked nighttime on Earth. That detail lands softly but hard too, because it means the crew could see not just our world, but our world mid-evening, already turning away from daylight. And now the story bends again. Expected, Earth as symbol. Actual, Earth as place. The comparison is almost embarrassingly ordinary, which is why it works. From deep space, our planet can look less like a grand globe and more like the last lit window on your street when everyone else has gone to bed. Jeremy Hansen told reporters the view up there was emotional, full of joy, happiness, and disbelief. He said it humbled them right away. That line feels important because astronauts are trained for systems, failure modes, and procedure. Yet what struck him first was scale and gratitude. It is hard to stay arrogant when the whole human world shrinks to something you could hide behind your thumb. And still, because they were human, the sacred kept rubbing shoulders with the normal. Koch joked that they might look at the far side of the moon in awe and then think maybe they should change their socks. That line is perfect. It is the whole truth of human spaceflight in one beat. You can stand inside history and still have to deal with your feet. Who would you send this to if they still think the moon is just a dead gray rock? Sharing helps this story reach people who might never realize how alive Discovery can feel, because right after Earthset, the flyby offered its most dramatic piece of darkness. Not the fake dark side from songs, but a real eclipse seen from the far side. Toward the end of the flyby, the sun moved behind the moon from Orion's point of view. NBC reported that the eclipse was expected to begin around 8:35 p.m. Eastern Time. Scientists expected a powerful sight, of course, but probably something brief, like the quick magic many people know from eclipses on Earth. What the crew actually experienced, according to NASA image notes, was nearly 54 minutes of totality, a long, suspended blackout with a glowing halo around the lunar disk. That duration matters. On Earth, total eclipses usually rush past like a held breath. From Orion, the moon blocked the sun long enough for the moment to stretch, settle, and become a working observation period rather than a blink. It was less like someone flicking off a lamp and more like the whole room staying dim while your eyes slowly wake up to what was already there. NASA's caption for the eclipse image said the science community is still investigating the glow around the moon. It may have been the sun's corona, the outer atmosphere, or zodiacal light, which is sunlight scattered by dust in the inner solar system, or some mix of both. This is where the story gets even better. Scientists will tell you they do not fully understand this yet, and that honesty is one of the strongest parts of real science. The models had predicted something cleaner. What the crew actually photographed raised fresh questions. That soft white ring was beautiful, yes, but it also refused to fit neatly into a single, easy label. It was like hearing a sound in your house and knowing it came from the pipes or the wind or the heater, but not yet knowing which one, even though you know it matters. Stars also became visible in the darkness, which almost sounds fake until you remember how much bright sunlight usually hides them. NASA said the moon's darkened disk and the long totality let faint points of light show up more clearly. Expected, the moon swallowing the sun. Actual, the black space around them filling in with other actors. It was the cosmic version of letting your eyes adjust after someone turns off the bright kitchen light. The fourth discovery puzzled scientists the most because it involved what might have been possible during that dark interval. Researchers had hoped the crew could look for brief flashes on the moon caused by small meteoroids striking the surface. That idea matters because the moon has no thick air blanket like Earth does, so space rocks hit directly. A flash there would be like a grain of sand sparking against stone, only scaled up into something a trained human eye might catch. Whether the crew saw such flashes clearly is not the strongest confirmed part of the story yet, and that matters too. Not every suspenseful question ends in a clean headline. Sometimes the best outcome is that astronauts bring back observations, images, and puzzles that scientists keep working through after splashdown. Good science is not a magic trick with a rabbit at the end. It is more like opening the oven and learning the middle still needs time. By this point, the mission had already broken a record. NASA's Mission Answers page said the crew would reach a maximum distance of about 252,760 miles from Earth. That is roughly 4,105 miles farther than Apollo 13's old record. If you want a grounded comparison, think of adding the width of the continental United States and then some to a record that already seemed untouchable. The exact timeline makes the moment even sharper. NBC reported the crew was expected to pass Apollo 13's distance at 1:56 p.m. Eastern Time on April 6th. NASA's own mission page placed their farthest point just after 7 p.m. that evening, with closest approach to the moon around 4,067 miles above the surface. Those are the kinds of numbers that stop being trivia and start feeling like fingerprints. History is often remembered in miles and minutes because those are the points where impossible things become measurable. And remember, this happened on a mission some people casually described as just a test. That is the underdog thread running through the whole flight. Artemis II was underestimated because it was not a landing mission, but a mission does not need boots in dust to change what humans know. Sometimes what matters most is who gets to look, from where, and for how long. This crew spent years preparing for exactly that. NASA's Johnson Space Center later recapped their geology training in Iceland, where volcanic ground gave them practice reading rugged terrain together. That sounds far from the moon, but it makes sense. Before you can understand a strange world, you train your eyes to notice shape, layer, fracture, and shadow, like a mechanic learning to hear a problem in an engine before seeing it. Reid Wiseman had talked about this years earlier on NASA's Houston, We Have a Podcast. He said they would not be in low lunar orbit but far above the far side, high enough to see something very different from a simple Earthrise. He called it a truly magical moment in advance. The remarkable part is that when the moment finally came, the real thing still seems to have outrun the rehearsed words. What would you ask the crew if you had 1 minute with them after splashdown, and would you drop that in the comments? Your answer helps me know which human side of these missions matters most to you. Because after all the numbers, the sharpest lesson of Artemis II may be about human eyesight itself. The crew kept saying the photos were amazing, but the real view was another level. That difference can sound poetic, but it is also practical. Cameras crop, expose, flatten, and choose. Eyes move, adapt, notice contrast, and change what they care about second by second. A human looking out a window can compare, search, react, and redirect attention almost like a living instrument panel. It is the difference between seeing a picture of the ocean and standing where the wind actually hits your face. The far side of the moon especially rewards that kind of seeing. Unlike the near side, it has fewer dark lava plains, which are called maria, and more rugged highlands. That means the familiar dark patches many of us know from the moon look reduced, shifted, or absent. So when Koch said the dark parts were not in the right place, she was not just speaking emotionally. She was describing a real visual shock built into the moon itself. That shock also tells us something about memory. Most people do not realize how well they know the front of the moon until they meet the back. We have all carried the same face of it since childhood, over playgrounds, highways, back porches, and apartment windows. Then Artemis II rounds the corner and reminds us that even our oldest sky companion has been keeping half its expression to itself. There is another reason the far side matters. Because it has been less flooded by ancient lava than the near side, it preserves a rougher record of the moon's early violence. Craters, basins, and ejecta patterns there help scientists piece together the bombardment history of the early solar system. In simple words, the far side is a battered archive. It is like finding the side of an old notebook that has fewer doodles on top, so the original writing shows through better. That does not make the near side less important. It just means the far side answers different questions. Scientists expected Artemis II to give them visually useful context for things robotic missions have mapped for years. What the crew actually added was human observational texture, a sense of lighting, spacing, contrast, and scale that can refine how features are described and remembered. A map can tell you where the stove is. A person in the kitchen can tell you how the room feels at dawn. This is also why the word reveal fits, but maybe not in the way clicky headlines mean it. The crew did not discover monsters, ruins, or secret glowing cities. They revealed something quieter and more honest. They showed that the far side is not spooky because it is unnatural. It is moving because it is real, detailed, ancient, and suddenly close enough for people to react to it in real time. When NASA released the first lunar flyby gallery on April 7, 2026, that honesty came through in the images. You could see a world defined by edge light, basin rims, layered damage, and black sky. You could see the moon eclipsing the sun and Earth dropping out of sight. The photos were beautiful. But beneath the beauty sat a simpler fact, which was that people had gone there again and looked carefully. Look at how much of the mission depended on tiny, ordinary systems still behaving. Email glitches had to be managed. The onboard toilet had issues and had to be worked through. Suits, airflow, waste, sleeping, timing, and food all still mattered while history unfolded a few inches beyond the windows. That contrast is almost the whole Artemis program in miniature, the future held together by hardware, patience, and people still trying to keep crumbs from floating into the wrong place. It also answers a question many people never ask out loud. Why send people at all when robots can go cheaper and longer? Because sometimes the value lies not only in data gathered, but in the kind of attention a person can bring. A human being notices surprise. A human being can say, without waiting for a later caption, "This is not the moon I am used to seeing." By the time Artemis II turned home, the far side was already behind them. But psychologically, I think it had moved into the front. It had become part of the shared human picture of the moon, not just a mapped backside, but a witnessed place. That matters more than it sounds. A thing humans have seen together enters culture differently than a thing known only through diagrams. Then came the return leg, long and steady. After the flyby, the crew spent days heading back, carrying images, impressions, and answers mixed with new questions. They were expected to splash down in the Pacific on April 10th, and NASA's recaps confirmed that they did. By then, the mission had covered about 695,081 miles, which is such a large loop it almost sounds unreal until you remember it ended in ocean spray and recovery teams. That final contrast is beautiful too. 1 week you are farther from Earth than any human has ever been, looking at Earthset from behind the moon. A few days later, divers are opening hatches and helicopters are carrying you to a ship. Cosmic scale collapses into procedure. Like coming home from the longest road trip imaginable and still having to unload the bags, space always returns to the level of hands, water, straps, and steps. So what did the Artemis II crew actually see on the so-called dark side of the moon? They saw that dark was the wrong word. They saw the far side, the hidden side, the less familiar side, lit by grazing sunlight and broken by long shadow. They saw giant basins, strange crater fields, an eclipse that lasted nearly 54 minutes, stars in the dark, and Earth slipping away behind the lunar horizon. But maybe more important, they saw relationship. They saw that the moon changes when viewed from the right path and the right distance. They saw that human eyesight still has a role in an age of sensors and robots. And they showed the rest of us that a mission framed as engineering can still become revelation. Not because space changed for them, but because angle changed. And angle changes everything. At the start of this story, the impossible image was a world falling behind the moon. That sounded backward. We expect the moon to be the mysterious one, and Earth to be the stable thing, the home thing, the fixed thing. Now the flip has happened. The moon feels more solid, more textured, more knowable, while Earth becomes the fragile, bright crescent slipping toward the edge of sight. That is the emotional mirror of Artemis II. At first, the far side seems excluded from us, a place we do not get to know. By the end, it has included us in its reality, and we have to answer by looking back at our own world differently. Few people once knew what the far side truly looked like with human eyes. Now all of us have a clearer chance to imagine it, and maybe to listen to what that view says about home. In dictionary terms, dark should mean absent of light, but in the way people use it, dark often means absent of closeness, absent of witness, absent of care. Artemis II dissolved that second meaning. The far side is no longer just the moon's withheld half. It is a place people have watched carefully, a place with names, shadows, timing, texture, and memory. And that may be the deepest reveal of all. The crew did not return telling us the moon was stranger than we thought. They returned showing us that we had been too lazy with our own picture of it. We called it dark because we could not see it. Now we know better. The hidden side was never empty. It was waiting for the right line of sight. So carry this with you after the video ends. Somewhere in the black between worlds, 4 people looked out from a spacecraft no bigger than a room, and Earth quietly set behind the moon. Not rose, set. And in that backward, beautiful moment, the old mystery did not vanish. It became clear enough to love.